Please subscribe math.com for any query, comment or email. Hello everyone. Today we discuss a very important topic, that is scientific notation. Now, what is the use of the scientific notation? Why do we use it? Basically, it is a way of writing the very small or the very large numbers for easier computation. So whenever we came across the numbers that are very large, we can apply the scientific notation there. For example, we have a number as, this is a large number. It can be written as 7 into 10 raised to power 7. But how? For the time being, you just keep your concept as, we can represent the numbers like this in the scientific notation form, because they are large numbers, and when we represent them in the scientific notation form, they become easier for computation. Okay, for how you can write the numbers into scientific notation, before that we have to discuss the concept of the powers of 10. Then we will move toward what are the rules to write the number in the scientific notation. First, you must know about some concept about the power of 10, as it is important in scientific notation. It is helpful, basically powers of 10 are helpful in writing large or small numbers. Instead of writing lot of zeros, power of 10 can replace that. Okay, so we are having two types of powers of 10, as the positive powers of 10 and the negative powers of 10. Okay, once you get the concept of these positive and negative powers, it will be easier for you to understand the scientific notation concept. As we have seen in our lecture when we studied the exponential forms, it is a property of the exponents that if the exponent is 0, what it will be then. Let's see, if we have a number that is 10 and its exponent is 0. Whenever the exponent is 0 and the base is any, then we will get 1. It means that the number is multiplying 0 times. If a number is multiplying 0 times, its answer is 1. Okay, so the 10 raised to power 0 will always be equal to 1. If we increase the power as 10 raised to power 1, what we will get? We will get 10, as you multiplying the 10 one time. Okay, then 10 square, it means you have to multiply the 10 two times. What you will get? You will get 100. Then 10 cube, it means 3 times we will multiply the 10. The answer will be 1000, and so on. This is how the positive powers of 10 are used to represent the large numbers. Like if you have 100,000, that can be represented in the positive power of 10 as 10 raised to power 5. Okay, now we move towards the negative powers of 10. If we have 10 raised to power minus 1, what does it mean? It means we have to move it in the denominator, and then we will divide it as by normal division method. We will get 0.1. Okay, then if we have a power like this, it means we will move it to the denominator. It becomes 10 square. Then it means 1 divided by 10 square means 100. 1 divided by 100 will give you with 0.01. Okay, then 10 raised to power minus 3, it will be 1 over 10 raised to power minus 3 plus 3. As it goes into the denominator, it becomes positive. Then 1 divided by 1, 2, 3. Okay, 10 raised to power 3 means 1000, and then what we will get? 0.001. So it's all about the positive and the negative powers of 10, how you can represent the large numbers. If you have 100,000, you will be given, and how you can represent in the powers of 10 so that you get a compact figure that can be easier for computation. Now we move towards the rules for how you can represent a number in scientific notation. There are two rules that you have to keep in your mind in order to easily convert the large or the small numbers into scientific notation. Okay, the two rules are, we will write them side by side, as the rule number 1 will be here and rule number 2 will be. According to the rule number 1, for numbers equal to or greater than 10, it means the larger numbers. Okay, rule number 1 is for larger. Okay, for numbers equal to or greater than 10, the rule is, so you can write by moving the decimal point to left. We have to move the decimal point to left. Okay, then to left at a place after first non-zero, at a place before first non-zero digit. We will see it how. Okay, and the power will be positive. Power of 10 will be positive. Let's see how. If you are given with a number, for example, we have a number 7, 1, 2, 3, 4, 5, 6, and you will be asked to write in scientific notation form. What you will do? You will start moving like this, and you will continue moving till you get a point where one non-zero digit left. So the point is here, okay, because after that point one non-zero digit, that is 7. You will write it in the form that you will write that digit as it is. How many digits you move the point? It's 1, 2, 3, 4, 5 and 6. As there are 6 digits that move towards left, then we will write the power of 10 as 6, and it will be positive because we are moving toward left. Okay, so that's why we have put the power of 10 as plus, and the 6 means there are 6, we have moved 6 digits to the left, and this number is now in scientific notation. So this is how you can write the number in scientific notation. A number that is greater than 10 or that is equal to 10 or greater than 10. It means this is the rule for the large. Now let's see what is the rule for the smaller numbers that are in point. For that we have a rule for numbers less than 0. Okay, let's see what is the rule, how you can convert the numbers that are less than 0 in scientific notation form. Moving decimal point to right at a place until we get a first non-zero digit. Okay, and the power of 10 will be negative. So this is the rule for the numbers that are smaller, that are so small that if we represent them in the form of scientific notation, it will be better because it becomes easier to compute them. Okay, let's have an example. If you have a number, like how you will represent it in scientific notation form. So where we have to move? We have to move toward right. It means you have to start moving there, and we have to move until we get the first non-zero digit. We get the first non-zero digit here. It means we have to put the point after this first non-zero digit. Okay, it means the given number becomes as 4.8. We have removed all the zeros and put the point after 4, multiplied by 10 raised to power. How many digits we have moved? We have moved 1, 2, 3, 4, 5. It means the power will be 5. It means 4.8 into 10 raised to power 5. This is the scientific notation form of the given number. So this is how you can find the scientific notation of the small and the large numbers. Let's have few more examples of small and large. We'll write large numbers here, small numbers. Let's practice few examples so we can have a clear concept. Okay, for large numbers, let's say we have a number. This is a number, okay, and the point 0, 0. Here the point it is. This is the place of the point. As it is a large number, we have to move towards right. Okay, so we have to move till one digit left. As we are moving, one non-zero digit left. So we came here when this non-zero digit left. Okay, now this number, how we can represent this number in scientific notation? As we will write how many digits we have moved. We have moved 9 digits, so it will be 10 raised to power 9. But here you have to keep in your mind, we can't drop these digits as we have already seen. As if these digits will be 0, then we can drop them. Here we cannot drop them, we can round off. Okay, so we cannot drop these digits here. So this is one of the example of the large number. One more example is how you can write them in the scientific notation form. Simply start moving towards left, 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 left till one non-zero digit left. This is the one non-zero digit left, so we will put the point here. Okay, so what we will get? We will get 5.6 multiplied by 10 raised to power. How many digits we have moved? 10 raised to power 11. So this is how we can write the number in scientific notation form. Okay, these were the two examples. Now we will take the example of the small number. If we have the small numbers, as how you can represent them in the form of scientific notation? You just first you have to move to the right from this point. We are moving towards right, right, right till we get a first non-zero digit. So this is the first non-zero digit. We'll put the point after that. Then what we will get? We will get 3.95. 5. Okay, multiplied by 10 raised to power, how many digits we have moved? 1, 2, 3, 4, 5, 6, 7. 10 raised to power 7 minus 7. Keep this in mind. Here it will be minus. When you express the numbers smaller than 0 into the scientific notation, the power will always be negative, and the larger numbers have the power positive. One more example, 0. Let's see how you can do with this. We'll move towards the right. We have got this digit and we have to place point after that. Then how you can write it as 3.0. You may also not write here 0. You can also write just 3 here. So 3 into 10 raised to power, how many digits we have moved? 1, 2, 3, 4. 10 raised to power minus 4. So this is the scientific notation form of the given number. So it was all about how you can represent the numbers in scientific notation, what are the rules, and why do we use scientific notation basically. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.